All right, today we've got something called implicit differentiation. It's another weapon in our arsenal to allow us to take derivatives. So here's the scenario. Let's suppose I've got something easy like y equals 2x minus 7. Is it safe to assume that you could all take the derivative of that? I would hope so, or the quiz is not going to be pleasant tomorrow. However, what if I gave you this? How would you take the derivative of that circle? Circle with a radius of 2. And technically speaking, in order to maintain a function, we'd only consider the positive part of that. But anyways, how would you take the derivative of that?
You just do like y equals 4?
Yeah. Solve for y. Bring the x squared over to the other side, take the square root of both sides, and we take the positive part because we only want the top half of the circle, and then take the derivative. So we would get something like y squared is equal to 4 minus x squared, so y is equal to positive square root of 4 minus x squared. And oh look, a chain rule pops up, but blah, blah, blah. Okay. What implicit differentiation does for us is it allows us to solve for derivatives in functions where we can't solve for y. So there's no algebraic way to pull the y value out of the function, so we have to figure out some other way to do it. That's a line. Stop it. Okay, hold on. So you should be able to do some implicit differentiation. Just 2 you should be able today. The other one of my pet peeves, you should know the difference between those 3 things.
I do know that.
Good. At this stage, you should know the difference. You should also understand why I put an extra space in there. I don't know why there's an extra space there.
Also 2, 2, and 2.
2, 2, and 2 is another good one. This one is more bothersome.
Oh, yeah.
Yeah. Here are the 4 calculus guidelines for taking implicit differentiation. You can write it down. It's not going to mean anything to you. Implicit differentiation is something you're going to learn more by doing, and initially by watching me, and then you'll get it. So again, if you want to write that down, that's okay. If it doesn't mean anything to you, which it probably doesn't right now, then don't bother. So I'm going to go through it quickly and get right into an example. Here we go. Now, let's refresh your memory about the notation there. dy dx, the derivative of y with respect to x. So what's my variable? X, correct. But in this equation, I can't get the y's by itself. I don't know how to solve for y. I don't even know if that is solvable for y. So we're going to use implicit differentiation. This is not too bad. In fact, to be honest, the calculus is pretty straightforward. It's the algebra that's going to cause all kinds of problems. So I'm going to go slow. If I lose anybody, please holler and I'll try to help you. Here's what you need to remember when you're doing implicit differentiation. Anytime you take the derivative of an expression in terms of y, you have to add something extra to it. So, for instance, what's a derivative of y cubed? 3y squared. But now I just took the derivative with respect to of y with respect to x, so I have to put a y prime after that. Okay. However, you might also want to do this. They're the same thing. Whether you want to use the Leibniz notation or the Newton notation, I don't really care. I find the y prime easier. However, you should also realize the advantage of this is that it tells you what you're doing here. You just took the derivative of y with respect to x. That's why that has to be there. Okay, let's keep going. What's the derivative of y squared? 2y y prime. Very good. Or 2y dy dx. Derivative of negative 5y? Negative 5 y prime, or negative 5 dy dx. What's the derivative of x squared? 2x. Minus 2x. No y prime, because it's just x. Or, if you want to get all fancies in your pantsies, You could do derivative of x squared is 2x, dx dx. What's dx over dx? 1. So we don't really need that because we're fairly bright. Okay. Here's the single most common mistake with implicit differentiation. You have to do it to both sides of the equation. What's the derivative of negative 4? 0. At least 5 of you, that's my prediction, at least 5 of you will screw up on this at some point in time. Okay, don't be one of those 5. Do you prefer the top line or the bottom line? Top? Beautiful. Good answer. Okay, we're done with the calculus. Nice job, everybody. Give it up. Yeah. Now the algebra. What do you think I have to do next? Nothing is one option. That's not true, but I need to get y prime by itself because I'm still looking for the derivative.
Move x to the right.
That's a good start. 3y squared y prime plus 2y y prime. I don't know why I'm dictating as I'm doing this. Okay, what next?
And then factor out of y prime.
I like it. Last step?
Divide both sides by.
Hey guys.
Hey, how's it going?
Good. Okay, all done. That's not that bad, right?
No.
Okay. Let's ask the fun question. How could we make it more interesting?
Throwing like a trig.
Could throw in some trig. Trig is always fun. What else?
Like higher powers.
Higher powers. I like it. Raise things to cubes and fourths and or 4 times and that kind of stuff. Good. What else?
Throwing like a z or something. I don't know.
Another variable. Yeah, because if you throw in another variable, then you'd have y primes and z primes.
Yeah.
Yeah, we don't usually do that because that's more multivariable calculus stuff. But yeah. Raise the whole, so throw some chain rule in there too.
Or some product.
Or some product and chain rule.
Or like a product that changes into quotient rule.
Ooh, nice. Or, oh, I don't know. Let's take a second derivative. Oh yeah, we're going to. Yeah.
Good more client.
The reason the second derivative is so much fun is because it's going to incorporate a couple of those things. It's going to incorporate a quotient rule. It's going to incorporate some pain and suffering. It's going to be fun. Okay? As much as I talk about not liking a quotient rule, I could turn this into a product rule, but it's actually easier to do as a quotient rule. Here we go. Let's see. I think we'll use blue this time. Okay. Y double prime is equal to big long gazinta bar. Denominator on the bottom square. Take the denominator, bring it up on top. Multiply that times the derivative of the numerator, which is 2, minus big honk in parentheses, the numerator times the derivative of the denominator, which would be 3, whoops, I lied. Undo. Hold on. Okay. 6y, y prime, plus 2, y prime. Close parentheses. Close parentheses. Yeah. Okay. So before I go back through that, do you see the quotient rule wrapped up in there?
Yeah.
Okay, good. So the question is, where did the implicit come from? This was denominator squared on the bottom, bring the denominator up, multiplied by the derivative of the numerator. Minus big honk in parentheses, the numerator, times this business right here is the derivative of the denominator. since I'm taking a derivative of y, I have to stick y primes on the end of it. So the derivative of 3y squared is 6y. I need a y prime. Derivative of 2y is 2. I need a y prime. The derivative of a constant is 0. It goes away. That wasn't too bad, right?
No.
Are we good? Oh, but guess what?
It's not done.
It's not done. Why is it not done? It should seem like we're done. I've solved for y double prime. That's what I wanted. Life is good. Are you stretching or do you have an answer?
I'll guess.
Okay, go ahead.
So we have y prime on the right side.
Oh, yeah. So what do you want to do with those y primes?
Get rid of them somehow.
How would we get rid of those y primes? Jacob?
Substitute them.
You bet you would. Oh, look, I know what y prime is. We just threw up in their mouth a little bit.
Probably a little bit. Will we ever have to do this on a test?
Yes. Okay, so let's talk about what to do with that beast now. A couple things can happen. I could just ask you to find a second derivative, which I just did. However, that is not an acceptable answer. Why?
We got a fraction within a fraction.
Got fractions within fractions. So you would have to get rid of that fraction within fractions. By multiplying by 3y squared plus 2y minus 5 over 3y squared plus 2y minus 5. I think we all agree that that would be horrendous, yes?
Yes.
So the simple solution is, let's not do it. Let's stop there.
Really?
We get
Do you feel cheated?
No.
Okay, then we're good. More than likely what's going to happen is you're going to get a problem like this where it's going to be something more like a tangent, equation of a tangent line to solve this problem.
Oh, so you just plug in.
Plug and chug.
Yeah.
That would be pretty cool, wouldn't it? Let's take a look at one. What do you mean for nothing? I've got a second derivative sitting right there and it's looking sexy.
Let's go.
Woo! That's beautiful.
Go Prospect Heights.
It has nothing to do with Prospect Nights, but thank you for that, Chair. Reminds me of an older, you ever see Bill and Ted's Excellent Adventure?
I have.
Do you remember the scene? There's a scene when they're giving their speech, and there's a guy up on stage, and he's an obvious, like, football, he's a stereotypical football John.
Yeah.
And he's just crashing in his speech, so he ends it with, let's go send Venus high, and everybody loses their mind together. Okay. Because I like to make things interesting, I wrote a problem here that incorporates a number of things. First of all, we need to do an equation of a tangent line. What are the two things we need for the equation of a tangent line? No.
Oh, slope.
The derivative.
Slope and a point. Slope and a point. I got a point. I need a slope. In order to find the slope, I have to take the derivative of that monstrosity. And to make things interesting, I decided to put in a chain rule with a product rule.
No, you didn't.
I did. It's right there. In implicit differentiation. Because I can't get that y squared out of there. I can solve for y on the one side, but the other side's a train wreck. Are you ready? This is going to be fun. Guys, bunch of poopy pants. I'm going to do it in blue. I should do it in white. That would be cool.
Oh, yeah.
Yeah. Okay, let's start with this guy. How many functions? How many functions? Two. Which one's on the outside? Squared. Bring the exponent down, reduce it by 1. Easy peasy. chain rule. What's the derivative of x squared plus y squared?
2x.
2y prime. Y prime.
2x plus 2y y prime equals.
3.
Okay.
Oh, we don't do that.
Let's stop there for a second before we do the other side. Is everybody good to go on the left side of that equation? Awesome. Right-hand side of that equation, I've got a 100. That 100 doesn't matter to anybody, so I'm just going to put it here and put a bracket in there. I'll just take my final answer and multiply it by 100. Uh-oh, x times y. Product rule. The first times the derivative of the second. What's the derivative of y?
1.
Y prime.
1
Y prime.
y prime. Plus derivative of the first, which is 1, times the second, which is y. Told you, that wasn't so bad, was it? Oh, it's about to get worse. So, in order to find the derivative there, I need to solve for y prime. I hope you can all appreciate how nasty that's going to be. It's going to be nasty to the point that I don't even want to do it.
I don't think
Therefore, in this problem, I can avoid it. What's x equal to? 3. What's y equal to? 1. Let's plug and chug first, and then solve for y prime, because we're sneaky that way. 60 times 6 plus 2y prime equals
What?
300y prime plus a hundo.
Where do you get the 6?
6 times 10.
Why? 3 squared plus 8 squared.
How'd you get 60?
Good question. Outside. How did I get 60?
6 times 10.
Because x squared.
Yeah, 9 plus 1 is 10, times 6 is 60. Because x is 3. 3 squared is 9. 1 squared is 1. 9 plus 1 is 10. 10 times 6 is 60.
9 plus 1.
2 times 3 is 6. 1 times 2, 2. Y prime, don't know what that is, left it there. 100, I distributed and substituted. 3 times y prime is 3y prime times 100 is 300y prime. Y is 1, 1 times 100, hundo. Yep. 360 plus 120 y prime is equal to 300 y prime plus hundo. Bring that over there. $1.80 y prime is equal to 260. Y is equal to, zeros cancel, 13/9.
Why do you? Where the Y prime go?
Oh. Sloppy. Whoosh. There we go.
Okay.
Good catch. Whew, that was close. Pregunta.
Armageddon.
Tell me please how you went from here to here.
What's X?
3.
What's Y? 1. Plug and chug.
That was better than expected.
That's the answer.
How we doing? No, not the answer.
I'm doing better.
What is the answer?
Y minus
Get
1
the equation,
is equal
and then
to
y minus 1 equals.
13 over 9 times x minus 3.
Hot diggity.
How'd you
My name's Bunchy and I'm
This is fun, right?
Yeah, I like all.
I like it.
David, you having a blast? I can tell. You got that glimmer in your eye.
That's a tear.
That's
That's a tear.
Problems? Questions?
Have you seen this Saturday episode?
Everybody have this? Can I erase it? No.
Yeah.
Where Stewie Oh, it's strength.
Okay, so let's do a little brain activity here.
No, the
Does
answer-
anybody not see that picture moving?
What the?
Really? Not at all? Nothing? Interesting.
I don't.
That happens every once in a while.
Mine starts and stops.
Like a train.
It moves if I look my eyes.
It's not moving.
Like your eyes in one spot, it's always moving. Really?
Yeah, that's weird.
I just moved the corners.
That's really funny.